Good afternoon, my dear students. My name is Lakshminarayana. This is Ellen brand of chemistry. Today we are going to discuss about effect of temperature and rate of reaction. Effect of temperature and rate of reaction. It is one of the most important factor which is influenced the rate of reaction. So please be remember, based on the effect of temperature, only the one factor they are given. The previous year questions, 5 questions are there. All these 5 questions will explain later. First we have to discuss the topic. So what is the topic? So here temperature increases, rate of reaction also increases. Rate of reaction also increases. It's very simple. Temperature increase avute, rate of reaction kuda increase. So why temperature increases, rate of reaction increases? Enduku temperature increase avute, rate of reaction kuda increase avutundi anante, sir, here one of the main important factor, that is when temperature increases, more number of molecules get active, more number of molecules get energy equals to the activation energy or more than activation energy. So please be remember, when temperature increases, so what I told, so more number of molecules get energy equals to or greater than activation energy. So once more number of molecules, the fraction of molecules get activation energy, then rate of reaction goes very fast. So that rate of reaction increases. So this is the factor actually. So we can say simply rate of reaction increases when temperature increases. So that is the reason. The reason is, so more number of molecules get activation energy. So that is what, when temperature increases, rate of reaction increases. So one of the example, for example, if you take, say, reaction between then hydrogen and oxygen. Actually, hydrogen and oxygen at room temperature is slow. At room temperature is slow. But if temperature increases, the rate of reaction also increases. That is one of the example. Then well-known reaction for you people are the KMnO4. When reaction with oxalic acid H2C2O4, so in the presence of H2SO4, nothing but, so KMnO4 acts as an oxidizing agent in this reaction. KMnO4 with oxalic acid in the presence of acidic medium reaction, that what it gives, then K2SO4 will be formed, plus MnSO4 will be formed, plus CO2 will be formed, plus H2O will be formed. So whatever this is, these are the reactants and products. This reaction at room temperature, it is slow actually. Room temperature దగ్గర ఈ రియాక్షన్ స్లోగా ఉంటుంది. But at 70 degrees Celsius to 80 degrees Celsius, rate of reaction is fast. The same reaction, when temperature increases, rate of reaction is going fast. Why? What is the reason rate of reaction increases means? Here at room temperature, maximum number of molecules are not having the activation energy. Once temperature increases, they can get energy which is equals to the activation energy. That is what, my dear students, when temperature increases, rate of reaction increases. Actually, the effect of temperature can be explained by 2 important points. One is temperature coefficient, second one is Arrhenius equation. Temperature coefficient గురించి మనం ఫస్ట్ మాట్లాడితే, టెంపరేచర్ కోఎఫిషియంట్ అనేది అప్రాక్సిమేట్గా రేట్ ఆఫ్ రియాక్షన్ని ఫైండ్ అవుట్ చేస్తే దెన్ అర్హీనియస్ ఈక్వేషన్ అక్యురేట్గా రేట్ ఆఫ్ రియాక్షన్ని ఎక్స్ప్లెయిన్ చేస్తుంది. సో ఫస్ట్ వీ హ్యావ్ టు డిస్కస్ అబౌట్ దట్ that is what we call temperature coefficient. We discuss the temperature coefficient. See, look my dear students, temperature coefficient. So what is the temperature coefficient? That we have to discuss now. So temperature coefficient ante enti? For any rate of reaction, for normal reactions, for reactions, for every 10 degrees Celsius, rate of reaction increases nearly to doubled or tripled. Rate of reaction increases for every 10 degrees Celsius raise in the temperature. Rate of reaction increases for every 10 degrees Celsius. Rate of reaction increases for every 10 degrees Celsius. For every 10 degrees Celsius. So what happens? Rate of reaction is doubled or tripled or 2 to 3 times. So for every reaction, for every 10 degrees Celsius, for reactions for every 10 degrees Celsius, rate of reaction is increases doubled or tripled or 2 to 3 times. So for every 10 degrees Celsius, for every increase of 10 degrees Celsius, for every raise in the temperature of 10 degrees Celsius, the rate of reaction. So 10 degrees Celsius rise in temperature, rate of reaction is increases, doubled or tripled or 2 to 3 times I told. So here, what is the temperature coefficient actually? So temperature coefficient nothing but that is the ratio of specific rates at two different temperatures which are differ by 10 degrees Celsius. So what is the temperature coefficient, you know? So I told that two rate constants T plus 10 degrees Celsius divided by KT, it is equals to temperature coefficient. The ratio of two rate constants or ratio of two specific rates. Rate constant ni manam emantam specific rates. So ratio of two rate constants at two different temperatures which are differ by 10 degrees Celsius is called temperature coefficient. So what is the temperature coefficient, my dear students? It is very important. What I told, the ratio of two specific rates, the ratio of two specific rates at two different temperatures which differ by 10 degrees Celsius is called temperature coefficient. Temperature coefficient. ఈ టెంపరేచర్ కోఎఫిషియంటే so nu that is 2 to 3 times. So doubled or tripled or tripled, or 2 to 3 times they are mentioned, in between the 2 to 3 times. So that is what they are mentioned here. So look, my dear students, this is actually then KT2 divided by KT1, it is equals to nu whole to the power delta T divided by 10 you have to take to find out the rate constant at when it is raised the temperature. When it is raised the temperature. This is the formula you have to take. This formula you have to take when two different rate constants are there. In case if you want to find out any rate constant when temperature coefficient is given. For example, say look at, if temperature coefficient is 2, then rate constant K2 it is equals to, so what I told, if temperature coefficient is 2, nothing but nu equals to 2, nu it is equals to 2, temperature coefficient is 2, then from this formula we are talking about, from this formula K T2 equals to nu, what I told, nu into delta T divided by 10, right, into KT1, so that in case nu value is 2, that means temperature coefficient value is 2, then K2 equals to, so 2 power delta T divided by 10 into KT1. This is the formula to find out KT2 at different temperatures. So the same thing, if temperature coefficient nu it is equals to 3, then tell me only, then KT2 equals to, so that is 3 whole to the power delta T divided by 10, then KT1. So this is the formula in case temperature coefficient is 3. Clear, my dear students? Yes. Then see, look at some of the examples which are temperature coefficient is 2, temperature coefficient is 3. So example number 1, that is H2 plus I2 gives rise to then 2HI. For this reaction temperature coefficient is 2. Then one more reaction, that is CH3 bond ONA, that is sodium methoxide we call, when it is reaction with ethyl CH3CH2Cl, then for this ether will be formed CH3O bond C2H5, then formation of NaCl. For this reaction temperature coefficient is 3. So when the temperature coefficient is 3 like this, then you have to use these formulas. So temperature coefficient అనేది జనరల్గా మనం దేనికోసం డిస్కస్ చేస్తాం, rate of reaction, how it is find out. So rate of reaction changes, how does it takes place, that we can find out by using temperature coefficient. Actually I told that before entering into this, then temperature coefficient can explain the rate of reaction and approximate, that's what they are mentioning here. Sir, it may be nearly doubled or tripled, nearly doubled or nearly tripled, or in between the 2 to 3 like this, but not exact, accurate ga explain cheyali ante, sir, we have to go for the Arrhenius equation. So that is second thing. So second important point is Arrhenius factor. See, look, my dear students, second one we are discussing Arrhenius equation. Arrhenius equation. So what is the Arrhenius equation? Arrhenius equation equation, yeah, look at my dear students, Arrhenius equation K is equals to A into 3 power EA divided by RT. This is the Arrhenius equation. Say, look at in this, all the factors I will explain, whatever the terms are there in it. That is first K equals to rate constant. Rate constant. Then EA, activation energy. Activation energy. Activation energy. T, absolute temperature. Absolute temperature, nothing but we have to take the temperature in the kelvins. Kelvins lo తీసుకోవాలి, not in the degree Celsius. So then one more factor A is there, Arrhenius factor. Arrhenius factor. Then one more, my dear students. So that is R will be there, or we know that universal gas constant it is. So gas constant value you have to take 8.314 joule mole inverse, then Kelvin inverse in case in the joules. In case the question is there in the calories, then 1.987 or approximately you have to take it as 2 calories mole inverse, then Kelvin inverse. So this is we call Arrhenius equation. Say, look at my dear students, once Arrhenius equation, if you take in the logarithms, say, look at whatever the Arrhenius equation is there. So that is K equals to A into E power EA divided by RT, right? Yes. So now that Arrhenius equation we are explaining in the logarithms and as well as in the even in the formulas, the questions will be there that we'll discuss. See, look at, so whatever the Arrhenius equation is there, K it is equals to A into E power EA divided by RT. It is Arrhenius equation, well known Arrhenius equation. By taking ln. So ln nothing but it is not ln brand of chemistry, right? So ln nothing but logarithms. In the logarithms ln, so the ln equals to 2.303. See, remember ln equals to 2.303 log base 10. So this is actually mari ln ante log base e. This is log base 10. Yes, clear? So by taking ln both sides in case if you take, see, look at ln k, it is equals to minus EA divided by R into 1 divided by T plus ln A. That you can take. This is the formula. See, observe the formula carefully. So it is look like y equals to minus mx plus c, like this will be there. Y equals to minus mx plus c. See, the m is slope, right? So this is we are taking as a slope. This is we are taking as a slope. Then c nothing but it is an intercept. So ln A we are taking as intercept. Then say, sir, ln k we have to take on the y-axis. Then 1 by t we have to take it as in x-axis. See, look at the graph. Look, my dear students, in case if you draw the graph, in between ln k versus 1 by t. So 1 by temperature, you have to take it as an x-axis. ln k, we have to take it as an y-axis. See, then actually the slope is negative slope, right? So negative value will be there. So negative slope, you can get the straight line like this. Positive slope, you can get the line like this. So this is the negative slope. So negative slope, then from here to there, that we call intercept, that we can get it is ln A. So slope is what? So slope it is equals to minus EA divided by R. So this is the slope. They will ask a question based on it, which is slope and which is intercept in case graph drawn between ln k versus 1 by t. They will ask a question based on it. How they will ask? If graph drawn between ln k versus 1 by t, what is intercept and slope? So like this they will ask a question. Look my dear students, what is the intercept man? Intercept is c. So c value what will be there? ln a. Then slope is what? Slope, it is equals to minus ea divided by r. This is the slope. Then this is intercept. Yes, my dear students. So look at, observe it carefully. Then one more equation I will explain. Then after later we'll discuss the question based on it. Say Arrhenius equation. For this equation, if you take for the same equation, if you take logarithms, so look at when we are apply the ln k, it is equals to minus ea divided by r into 1 by t plus ln a we are taken, right? In the place of ln nothing but what will be there? 2.303 log base 10. So in the place of ln 2.303 log, then base 10, just assume it is a base 10. So log k, it is equals to minus ea divided by r into, so 1 by t. So wherever the ln is there you have to substitute, it is 2.303 log a. Clear? So now divide the equation with 2.303. Divide the equation with the 2.303. So in case when it is divided with the 2.303 cancel, then you can get it is log k, right? Then here minus ea divided by 2.303, then r t you can get, right? Or sir, of course 1 by t. Then so in the place of ln we are taken, this is 2.303 cancel, plus log a you can get. See this even this equation also, it is very important equation, my dear students. Even this equation also, it is look like y equals to minus mx plus c. See once again, so intercept is log a, then slope is negative slope, that is 2.303 r, which is minus ea divided by 2.303 r. So intercept that is equals to log a, slope that is equals to minus ea divided by 2.303 r. Clear, my dear students? Yes, observe it one more. Observe the question carefully. So what I told, look at, please, if you draw the graph for again both, so on the x-axis and the y-axis, what you have to take? So this is the y-axis and this is the x-axis. On the y-axis, what you have to take? Log k you have to take. So this is the log k. Then on the x-axis, what you have to take? 1 divided by t, nothing but 1 divided by absolute temperature. So again, the slope is negative, so that's what you can get the straight line like this. Remember, positive slope you can get like this, positive slope you can get like this, negative slope you can get like this, downwards. Clear? So from here to there, so log a we call, that is intercept. Then slope we can write, slope it is equals to minus ea divided by 2.303 r. Okay, so this is the Arrhenius equation when apply ln, when apply log. Surya Kumar, hi sir. Surya Kumar, hi. Sunny Gaming, hi. Yes, my dear students. Then we'll go for derivation of activation energy. See, subscribe my channel, my dear students. The derivation of activation energy we are discussing. Derivation of activation energy. That is activation energy, nothing but what? EA. So how can you derive the activation energy? So first, if K1 and K2 values at the different temperatures, if you take, if K1 and K2 are rate constants at two different temperatures T1 and T2, then Arrhenius equations if you take. So log applied Arrhenius equations, log K1 it is equals to, then log A, say look at log A, say intercept mundu rasanu, so log A minus, then EA divided by 2.303 or T1. Then this is equation 1, just assume it, this is equation 1. Then one more equation I am writing, that is log K2 it is equals to log A minus, then EA divided by 2.303 or T2. This is equation number 2. Subtract the equation 2 minus equation 1. Then log K2, see look at log K2 minus log K1, it is equals to, so K2, this is the formula. Then what will be there? Log A minus, then EA divided by 2.303 or T2. Close that. Minus the minus of that log A, what will be there? Minus EA divided by 2.303 or T1. Clear? Close this. So log A minus log B, like it will be present. So that you can write it is log K2 divided by K1. Log K2 divided by K1, it is equals to, then log A, so here when it is multiplied with minus, then log plus log A minus log A, both will be cancelled. Then next what will be there? Minus EA divided by 2.303 or T2. Then minus into minus plus, you can get plus EA divided by 2.303 or T1. So in the both cases, EA divided by 2.303 or EA divided by 2.303 r. So both we can take it as common. K2 divided by K1, it is equals to, see look at my dear students, EA divided by 2.303 r common తీసుకున్నాను. Clear? Then 1 divided by T1, so this is positive 1, minus negative term 1 divided by T2, negative term, that we can take. So for this we can also note it as, then log K2 divided by K1 equals to EA divided by 2.303, yes my dear students, or then T2 minus T1 divided by T1 into T2. So this is the formula to find out activation energy. Activation energy find out cheyadaniki, this is the derivation actually. So indulo slope enti, intercept enti, so ivanni manam find out cheyalsi untadi. So that is the most important equation for you people. Clear my dear students? So now from this previous year questions, so whatever the previous year questions are there, based on these topics, see the previous year questions, whatever it is there, that we'll discuss now. Chemical kinetics nunchi కొన్ని క్వశ్చన్స్ టెంపరేచర్ ఎఫెక్ట్ మీద ఎలాంటి టైప్ ఆఫ్ క్వశ్చన్స్ ఉన్నాయి, అనే దాని గురించి మనం డిస్కస్ చేద్దాం. సో ప్లీజ్ సబ్స్క్రైబ్ మై ఛానల్ మై డియర్ స్టూడెంట్స్. Subscribe all of you. Yes. See, look at one of the question based on it. The specific rate constant of decomposition of a compound. The specific rate constant of decomposition of a compound is given by ln k. It is equals to 5.0 minus 12,000 divided by T. The activation energy of decomposition of this reaction. The activation energy of decomposition for this compound. Decomposition for this compound at 300 kelvins. This is the question. Observe it carefully, my dear students. This question is given 2020. Then September lo adigina question ide. September lo adigina question. So look at so here A option will be there. 24 kilocalories mole inverse. Then B 12 kilocalories mole inverse. Then C 24 calories mole inverse. Then D 12 calories mole inverse. So like this is given. Question ila ichcharu. Observe the question carefully, my dear students. So what is there in this? One of the specific rate at K. So equation is given. So this equation look like the previous when Arrhenius equation ki ln apply చేసినప్పుడు ఎలాంటి ఈక్వేషన్ వచ్చిందో సేమ్ ఈక్వేషన్. Arrhenius equation కి ln అప్లై చేస్తే సో ln అప్లై చేసినప్పుడు ln k ఈక్వల్స్ టు వాట్ వి కాల్ సో ln a minus EA divided by RT. So this is the formula we got, right? So the same type of formula is there even here also. So that is actually ln k as usual will be there. So in the place of ln a 5 is there minus 12,000 then divided by t is there. So actually these two terms are equal, right? These two terms are equal. So I am taking that is minus E divided by RT. It is equals to minus that is 12,000 divided by T. Say in the both cases temperature is cancel. Minus cancel. Then what is required? EA is required. EA equals to 12,000. Nothing but we can take it as 12 into 10 to the power of 3. Say into then R value. So R value the calories lo ichchadu kabatti R value calories lo enta 2. So 12 into 2 24. So 24 into 10 to the power of 3. So 10 to the power of 3 we call it as kilocalories, right? So 24 kilocalories per mole, that we call mole inverse. Remember, my dear students, the R value we are taken in this case, R equals to 1.987 or 2 calories approximately. Clear? Understand all of you? Yes, this is the question. One of the previous year question it is. The same type of question, one more is there. See, that also will discuss. Look, my dear students, one more question I will explain based on it. The EAPCET examination lo ichina questions ivani. So EAPCET of examination questions. Yeah. So look at, my dear students, one more. The first order reaction A gives rise to B. For the first order reaction, for the first order reaction A gives rise to B. The temperature T dependent rate constant. The temperature dependent rate constant the temperature dependent rate constant K in second inverse was found to follow the equation. Was found to follow the equation. Follow the equation. That is log K, it is equals to minus 20 divided by T plus 4. The activation energy and Arrhenius factor A respectively. So this is the question is given in the 2020 September 11th kadigina question idi. So this is also the most important question. So actually the options are mentioned, that is option A 46.06 calories mole inverse, then 10 to the power of minus 4 second inverse. Then option B, that is 92.12 calories mole inverse, then 10 to the power of 4 second inverse. Then C, 46.06 calories mole inverse and 10 to the power of 4, that is second inverse. Then D, 9.212 calories mole inverse and 10 to the power of minus 4 second inverse. See, look my dear students, even the question here, the log K equals to, then minus log K, when it is apply the log K equals to minus EA divided by 2.303 R T 1 by T, then plus log A, like this will be there. The same equation. So even here, so log K equals to minus 20 divided by T, then plus log A is mentioned. So log, not log, 4 is mentioned. So log A equals to 4 you can get. Then this is total value, you can get this, right? So minus EA divided by 2.303 RT equals to minus 20 divided by, so T. So TT cancel, right? Then minus cancel, right? Then EA equals to, then 20 into, then 2.303 into, then R value 2. See, look at, so this total you can get it is, so you can get it is 92.12 calories, the mole inverse you can get like this. So this is the formula you can get, this is the answer you can get for this. Then what about the, this is, so log A equals to 4 is there. Then A is required, then anti-log 4 you can get. So anti-log 4, that it will be, so 4 into 10 to the power of, that units are second inverse. So 10 to the power of 4 second inverse, not minus 4, 10 to the power of 4 second inverse you can get. So the both, you can get the answers like this, my dear students. Yes, understand. Then 2 more questions are there. So you can solve that 2 more questions based on Arrhenius equation. So look at calculate the activation energy of reaction. That is question August 2021 August 5th కి ఇచ్చిన క్వశ్చన్. Calculate the activation energy of reaction. Calculate the activation energy of reaction. Calculate the activation energy of reaction whose rate constant doubles on the rising the temperature. Whose rate constant doubles on raising the temperature from 300 kelvins to 600 kelvins. They are given like this. Options are mentioned, my dear students. Sir, option A 3.45 kilojoules per mole. Then option B 6.90 kilojoules per mole. Then option C 9.68 kilojoules per mole. Then option D 19.6 kilojoules per mole. So this is the question. Yeah, so look at my dear students, this is the question. So which formula we have to use for this question? So two different temperatures are there. Then rate constant will double when temperature is raised. So two different constants, rate constants, log K2 divided by K1, it is equals to then EA divided by 2.303 R, then T2 minus T1 divided by T1 into T2. This is the formula you have to use. So this is doubled, they're mentioned clearly. So log 2 value. So log 2 you can get. So that is 2K1. K1 cancel, then 2. So then EA activation energy you have to find out. Then 2.303. Then in the place of R, sir, in case it is there in the joules, you have to take 8.314. Sir, in case the values are there in the calories, you have to take 2 calories. So here the joules will be there. So 8.314 actually. Then look at my dear students. Here the T2 minus T1. So T2 is 600. T1 is 300. 600 minus 300. 300 you can get. 300 divided by. So when it is multiply both T1 into T2. Sorry, T1 into T2. So then 18, then 4 zeros, right? So 2 zeros, then 2 zeros cancel here. Then 3 ones are, then 3 6 are 600, it will be there here. Then activation energy is required. So activation energy equals to, this is required. So send this side, log 2 value is what? 0.3010 into, then both when it is multiplied, you can get 19.14 something, you can get exact, not exact, 19.4, 19.14. So like that you can get into 600. Then if you do this, the 3.45 into 10 to the power of 3 joules mole inverse you can get. So this is calories. So 3.45 into 10 to the that is kilojoules per mole. This is the answer, my dear students. So this is the question for this. Understand all of you? So what formula you have to use? Log K2 divided by K1, EA divided by 2.303R, T2 minus T1 divided by T1 into T2, then log 2 equals to EA divided by 2.303. So this R value you have to substitute in the joules because options joules lo unte joules nu substitute cheyali. T2 minus T1, 600 minus 300, so 300 you can get. When it is multiply T1 and T2, then 3 6 are 18 into 4 zeros, then above 2 zeros and below 2 zeros cancel, then 3 1 are 3 6 times 2 zeros, then when it is all multiplied you can get this value. Clear? So one more question will be there based on it. That also will discuss, my dear students. Please listen carefully. Sani Gaming, Surya Kumar, Suraj Kumar. Yes, look at Suraj Kumar. Look at, my dear students, one more question we'll discuss. I won't look at who are listening my classes, because all these classes will be there in my YouTube channel. So in case if anybody want, so you can search my channel, that is LN Brand of Chemistry. Then subscribe my channel. Whenever we are doing the live classes, you can get a notification. Yes, clear, my dear students. Then one more question we'll see based on it. That the rate of reaction doubles. The rate of reaction doubles. The rate of reaction doubles with every 10 degrees Celsius rise in temperature. If the reaction is carried out in the vicinity of, if the reaction is carried out in the vicinity of 22 degrees Celsius, the activation energy of the reaction is, activation energy of reaction is EA. Activation energy nothing but EA. Options are 1.69, then 0.169, then 49.8, then 498. This is joules only, this is kilojoules. Then all the above are kilojoules per mole. A, B, C, then D. See, look, my dear students, observe it carefully. Whenever they will mention the rate of reaction is doubles when raise the temperature, that means the ratio of rate constants of two different temperatures is doubled. So, my dear students, the same equation that we have to take, Arrhenius equation, the energy calculation equation. What is the energy calculation equation? What will be there? Log K2 divided by K1 equals to EA divided by 2.303. Yes, tell me. Or then T2 minus T1 divided by T1 into T2. Yes. See, look at. So whenever reaction is doubles, they're mentioned, you have to take K2 divided by K1 ratio, you have to take 2. In case they will mention tripled, 3. Then in case they're mentioned quartered, then you have to take 4. So here log 2 have to take EA divided by, so 2.303. Sir, it is there in the joules, R value, you have to take 8.314 joules. Then in T2 minus T1. Sir, here you must know what is the T1 and what is the T2. So T1, it is equals to 22 degrees Celsius. That must be converted into the kelvins, my dear students. By the addition of 273, what you can get? See, look at 273 plus 22. So 5, 9, yes, 295. Then T2, by the addition of 10 more degrees Celsius for this. See, for 295, in case if we add 10 more, then 305 you can get 305. This is T2, that is T1. Clear, understand all of you. So 305 minus 295, then you can get it is 10 divided by, then 295 into 305, then it is multiply both. Then what is required? A activation energy, EA activation energy is required. Then log 2 value I told that 0.3010, my dear students. Then when both are multiply, 19.14 nearly can get. Then these two, so the such as 295 into 305 divided by 10. So when all these doings, if you get 49.8 kilojoules per mole, you can get. This is the answer, my dear students. Okay. Even this is also one of the previous year question. It came in the 2020 September 9. 2020 September 9th kadina question idi. The most important questions, all these, a temperature effect. Effect of temperature. If EAPCET classes are Kiran Kasi. EAPCET classes AV. Hello Kiran. Kiran K. So all these are EAPCET classes only. All these are previous EAPCET questions only, what we are discussing based on the topic of effect of temperature on rate of reaction. See one more factor based on the activation energy. One more question is there. So that question also will discuss later. The remaining topic, whatever it is there in the effect of temperature, that will discuss. Yes, my dear students. See, note down one more question which is required to you people. For a reaction, this question actually, it is given in the 2020 September 9. Even this is also. The previous one, shift 1 lo iste, this shift 2 lo ichna question. For a reaction, A gives rise to B, the energies of A and B, the energies of A and B are 30 and 60 kilocalories per mole respectively. Then energy of the activation for backward reaction is 93. Energy of the activation for backward reaction is 90 kilocalories per mole. All are kilocalories only. The energy of activation for the forward reaction is so options ichadu 30, 123, C 153, D 90. ఇలా ఇచ్చారు. So observe the question carefully. Actually ఎంథాల్పీ ఆఫ్ రియాక్షన్ ఫైండ్ అవుట్ చేయడానికి యాక్టివేషన్ ఎనర్జీకి కొంత రిలేషన్ ఉంది. సో డెల్టా హెచ్ ఈక్వల్స్ టు ఎంథాల్పీస్ ఆఫ్ ప్రోడక్ట్స్ మైనస్ ఎంథాల్పీస్ ఆఫ్ రియాక్టెంట్స్. Enthalpies of products nothing but energies of reactants minus energies of products. See, look at my dear students. The energy of product, how much is given? Product is what? B. B value how much is mentioned? 60. A value how much is mentioned? 30. So 60 minus 30, you can get 30 kilocalories per mole. This is delta H value. For the same delta H, it is relation with activation energy. Activation energy of forward direction minus activation energy of backward direction. See, delta H value is there 30. It is equals to activation energy of forward reaction that you have to find out. EA of F you have to find out minus. Then activation energy of backward reaction is given 90. Clear, understandable of you. So activation energy of forward reaction equals to, so 90 plus 30. 90 plus 30, you can get, so 120, right? So that is 120 what kilocalories. This is the question, my dear students. So these are the answers what we are discussing now.